Alright, so hello and welcome. In this video we are going to build a database containing intraday cryptocurrency data for 20 coins and use that to analyze if we could have made profits using a certain trading strategy. The goal of that in general is to be able to backtest strategies on multiple time frames, such as 1 minute, 5 minutes, 30 minutes and so on. There are some prerequisites to better follow along this video. You don't necessarily need a Binance account but need the Python Binance lib installed. You should have watched my video on SMA as I'm taking concepts from there, for example the return and strategy return calculation, so I'm not going into details here. In general, you should be familiar to connect Python or more specifically Pandas to a SQLite database. Everything you need will be linked in the video description. The example strategy which we are applying to the intraday data is pretty much straightforward. We are in the position as long as the fast SMA is above the slow SMA. Important disclaimer, my videos should never be seen as investment advice. Technical indicators are no guarantee for profitable trades. Cryptocurrencies are not regulated and the Python Binance library is not an official library. Alright, so let's get started with creating and populating our database containing 1 minute granular cryptocurrency price data. As you see, I already did some stuff here, so I'm importing TQDM to get a progress bar for a loop we are running, Pandas for data handling, and the client, which I'm also instantiating here to get information from Binance, in our case, the historical price data. We also need SQL Alchemy to create a SQLite database and connect to it to, for example, populate it or later access data from it. I also created a tuple here which is containing the top 20 market cap cryptocurrencies in relation to the US dollar. So you can use web scraping to get those information. I will just link this tuple in the video description so you don't have to type that down. Now I'm creating a function, getMinuteData, to get price data, 1 minute granular, for a particular cryptocurrency pair. So for example, the Bitcoin, and I'm going back X days. So this is my look back period in days, right? And within this function, I'm defining a data frame using the data frame function from Pandas. And here I'm using the client and get historical K-line data or candlestick data. And this is taking the provided symbol. We are interested in 1 minute granular data. And we are going the look back days ago UTC. Right? So let me quickly return the frame so that you see what we are getting with that. So let's say we want to pull price data for the Bitcoin. We're going 1 day back. Oh, get minute data, of course. And with that, we are getting this cryptic data frame here, right? And as I already explained in one of my older videos, we only need the first 5 columns here, right? Because the first column is containing the timestamp in a Unix format, as you see here. So we cannot really read this timestamp yet. We will change that in some seconds. This is containing the open price, this is the high, this is the low, and this is the close price. How can I know? It's in the API documentation. So first of all, we are slicing this data frame. So we are just slicing for the first 5 columns using ilog, first 5 columns here. And then we are naming those columns. And first one, as I said, is the time. Second one is the open, then the high, then the low, and then the close. And let's print that out again. And with that, we are getting a data frame like this. All right. And now we need to do some, transformations. So this is string format right now, and we want to have these columns as floating values to be able to calculate with them, right? So we are using frame index for the open, high, low, and close columns, and we are just transforming that to a floating value as type float. Okay, so this is transforming those string formatted values in a floating value. The time column we are transforming to a human readable timestamp. So we are just using frame and use the time column. Use PD to datetime, provide the time column, and set the unit to ms. And with that, we're getting a data frame like this. So we have a timestamp, the open, high, low, close as floating values. All right. And now we just want to create data frames like this, going 30 days back, and write them into a database. And we can do that with a simple loop. But first of all, we have to define an engine. So I'm getting rid of that, define an engine. And this is just creating a SQLite database, which we can populate then. So we're using SQLite. Then just call that, I don't know, cryptoprices.db. And this is the database we are working with. And now we are just using a loop. So we are looping over those pairs, pull the price data, and write them into our SQLite database. So we're using for coin and coins. And to get a progress bar, as this will take some time. So this loop will run roughly 20 minutes, right? If you want to go back more than 30 days, will even take more time. So tqdm to get a progress bar for this running loop. And now we're just calling this getMinuteData function, provide the coin and the look back, and we said we want to go 1 month back. Write that to SQL. Give the table name, we're just naming it after the coin we are providing. Then define the engine so that we know to which database we are writing this. And this is the crypto prices database. We are setting the index to false, as we currently have an integer index and we just want to have the time, the open, the high, the low, and the close into our database. All right, and let's run this. And as you see, 20 iterations because we have 20 coins, and I'm not quite sure how long an iteration is taking. So when I tested it was like, I think around 1 minute per iteration. So of course, if you have a more efficient way, feel free to comment that. But I think it's quite a fair way to do that. Just let it run. I don't know, make yourself a coffee, come back and have a very nice database. So I'm just waiting for the first iteration to be over so that we can see how long it took. And as you see, we have an iteration time of 1 minute and 10 seconds. So yeah, this will take more than 20 minutes to run. But you will have a database containing 1 minute granular price data for the last 30 days for all 20 cryptocurrency pairs. So quite a fair deal. Alright, so as you see, the loop went through and we have successfully populated our database. So let me quickly give you an example how we can access the data from the database. So I'm just creating a quick test variable here. So I'm using the read SQL function from Pandas, and let's just take the Bitcoin table as an example and provide the engine. And with that, we are getting a data frame like this, containing 1 minute granular data for the Bitcoin. So more than 40,000 rows for 1 month or 30 days. All right. So what I'm doing here is, or what I'm doing now is to set the index of the data frame, which is currently an integer index, to the time here. So I can do that by just using set index and then time, and then have a data frame like this, lucid. So I have the timestamp and OHLC data here. All right. Now next, we want to create a function which is doing the SMA calculation for us. And as said in the beginning, I'm just using a very similar function as in the SMA video here. So I'm calling that function technicals, and this function is taking a data frame as an argument, and is first of all making a copy of the provided data frame so that we have the original data frame as the original data frame and do the manipulations on the copied data frame. Now we are doing the return calculation by creating a return column here, and I'm using log returns here. Or I have to import NumPy first, sorry for that, didn't do that in the beginning. So taking the log of the percentage change of the close price plus 1. So just simply the log return of the close column here. So I've explained that in detail in another video. I will also link that in the video description. Now I want to have the fast SMA, which is just rolling over the close column, and I'm just taking the Binance parameter. So there the fast SMA is 7 time step SMA, and the slow SMA is a 25 time step SMA. Then taking the mean, and with that I've calculated my simple moving average over the short term here. Same for the slow SMA with a 25-day window. And finally, I want to just know where I should be in the position. And as said in the beginning, I want to be in the position when the fast SMA is above the slow SMA. So I'm creating a new column here, position, use NumPy where, and then check for the fast SMA being above the slow SMA. And if that's the case, I want to have a 1, and if not, I want to have a 0. So if you want to implement short selling, this could be a -1. Now, based on that, we can calculate the strategy return. And the calculation is pretty straightforward. We are simply multiplying the position column with the return column. Makes sense, right? Because when you have a 1 here, you are in the position, so you are taking the return of the asset. When you have 0 here, you're just taking 0 times the return, so no return here. All right? There's one more thing you have to do, and I explained that in my SMA video as well. You have to shift the position by 1 row, because you cannot directly enter the position when you have a 1 here. So you can only enter it in the next possible time step here, right? So we are taking the position column, shift it by 1, and multiply that with the return column. Finally, as we're getting a lot of NaN values due to rolling functions and the PCT function, we are getting rid of them using drop NA and return the data frame. All right. Now let's call that function on our test data frame and see what we got. So as you see, we are getting new columns here, return SMA fast, SMA slow, the position, and the strategy return like this. So how can we calculate both the return of the Bitcoin and the strategy return and compare them? As these are log returns, they are time additive, so we can sum them up and take the counter function of the log, which is the exp function. So let's do that. NumPy exp, call the function, take the test data frame, and take a look at the return column and the strategy return column and sum it up. So as you see, Bitcoin lost roughly 25% over the last month, and the strategy only lost roughly 12% here, right? So if you want to show it in another way, we can just subtract the 1 here and see Bitcoin lost roughly 24% and the strategy return roughly 12.5% here. All right. Now let's do that for all 20 coins. So we can just loop over our coins tuple here and create a data frame for each coin here, right? So we're using, again, read SQL, provide the coin and the engine, and set the index to time. And now we are printing out the coin so that we are seeing which coin we are considering. And we are just using this one here and change test to the data frame containing the prices for each coin here in each iteration. All right, so if we're doing that, we are getting those results. And just in case you're wondering, I think 2 days ago, I posted a community post where I was using these numbers, but without the -1 here. So it's essentially the same. And what we are seeing here is, quite surprising, if not unbelievable, right? Because the strategy is always outperforming the benchmark, which is the return of the coin itself, right? We even got positive returns when the asset was dropping without short selling or something like that, just by following the strategy. And that's kind of insane on the first side, right? So again, you see here, we are always getting better returns. We're getting insane returns here, right? Insane. But, and this is the point, the question is, what are the costs to achieve a strategy return like that? And the answer is in the number of trades, because for each trade, no matter if it's a buy or if it's a sell, we have to pay 0.075%, right? And we have to consider those costs. But how often did we pay them? We can find out by taking a look at the position column. So let me quickly pull the test data frame again. And whenever this position column is changing, right, we have to take action. So we are either buying or selling the asset. And how can we find that out? I mean, it's 43,000 rows. We can just take a look at the difference. So Pandas has a difference function. I'm using that pretty often in my videos, where we are just taking the difference of 2 rows, right? So this one would be 0, this one would be 0, and so on. So whenever the difference is 0, we don't have to do anything. We are not executing a trade. But when this difference is either -1 or 1, we have to pay the fees, right? So let me give you an example. I hope I'm catching one. Take a look at the tail. Yes, here we got one. So imagine we are calculating the difference of those 2 rows here. 1 minus 0. Now we have 1. So if we have 1, we have to buy the asset, or we bought the asset rather, right? And if we have -1, we sold the asset. Just imagine it's vice versa. So we have 1 here and 0 here. Then we have 0 minus 1 and we have -1. All right. So how can we find out whenever this is happening among 43,000 rows? We can apply on the position column, we can apply the diff function to calculate this explained difference here. And then we're just counting the values. We have value counts here, right? And with that, we are getting 41,000 where we don't have to take action or where no buy or sell was occurring. And we have 1,087 buys and 1,087 sells here. All right. So we can actually put that into our loop formula, right? So we need the sum of these 2 values as the number of trades, right? So we can just take ilog and then just exclude this value, because here we don't have to do anything, and then take the sum here, right? So we have 2,174 trades, right? So we can take this number and multiply it with 0.07%, so 0.075, right? So why? Just in case you're wondering, because of that, right? It's a percent number. Okay, so, and this is quite insane, right? So we need to have a return of at least 163% to cover those trading costs, right? And now let's apply that to our loop and see if we made profits at all, right? So what do we have to do? We need to amend some stuff here. So first of all, after the coin, we have to calculate the trades, right? Because they're different for each data frame or for each coin, of course. So we are applying the technicals function on the data frame. Take a look at the difference of the position, count the values, exclude the non-trades, and then take the sum of that. These are our trades, and now we are just calculating the costs by multiplying the trades with the trading fees. All right. And now we have to change this one here because the return stays the return, right? This is nothing which is changing. So I'm just amending this here, subtracting a 1. That should be right. And now for the strategy return, we're using the same here, strategy return, but we are subtracting the costs here, right? And now let's see again. As you see, return stays the same, but the strategy return is super bad. You see it here, right? We don't have a single case where we are outperforming our asset. All right, quite disappointing, right? So did I waste your time with that? Well, maybe, but let me show you something. Let's do another thing, and that is take a look at another time frame. And now it starts to get interesting, at least in my opinion, right? So what if we're taking another time frame? If we're taking another time frame, the probability that we have such a high number of trades is getting lower, right? Because we have less signals. So how can we do that? We can take a look at the technicals function and just resample our data frame, right? So let's, for example, let's for example just take 3 minutes and just forward fill values here. I think we have to drop NA values here, otherwise the log function might not work. So let's take a look at the 3 minutes time frame and run it again. Still bad, right? Still bad. Now let's take a look at the 15 minutes time frame. By the way, of course, you can take that as an argument of this function would be way better. Now 15 minutes. And now you see we're getting better ones. Not in every case, right? But at least for the Bitcoin, we're getting a better return. For Ethereum, we are getting a slightly worse performance here. BNB, worse. Sol, way better. Do you make profit anywhere? Yeah, but slightly worse, right? Now let's take a look at the 30 minutes time frame. And here you see, better, better, worse, worse, better. and so on. I don't want to bore you, so play a bit around with it for yourself. One more, 60 minutes. All right. So, quite interesting, quite exciting, at least in my opinion, these insights. There is one more remark or bias I want to share with you. So our assumption here is that we are always buying for the close price, right? But this is far from the reality. We could achieve a better price or even a worse price than that, right? So the only real way to find out the true profit of the strategy would be to get even more granular data, right? And the possibility to do that would be to work with the WebSocket stream or the Binance Socket Manager would be possible. And then you're just feeding 1 second granular data to a database. That being said, let's get to the most important part of this video. I'm going to build a bot trading the strategy. That means no downside safeguard, no risk management, just following the strategy. And the special thing will be that on my desperate search for likes, the investment amount will be decided by you. Runtime of the bot will be 5 days. Of course, everything will be 100% transparent and will be shared with you. So, thank you very much for watching. Let me suffer, and I'm looking forward to seeing you in the upcoming videos. Bye bye.